this presentation, we'll go over the second set of practice problems. On this first one, we have a conjunction as our main operator in the conclusion. So we need to prove P, and then we need to prove T. So we're looking at our proof, see if we can derive either one of them individually, and then we'll just put them together, and it doesn't look like we're going to be able to do that. There's only tilde P and tilde T, so let's start with P, and let's assume it's opposite, has a PA, and then look to prove a contradiction. So with tilde P, we can wedge in tilde T. That's going to be 4, wedge in. And we're doing that so we can toss it into the conditional statement in 1 to get tilde Q, which is 1 and 5, arrow out. 4. Now we can toss this tilde Q into the conditional statement 2 to get S. So that's going to be 2 and 6, arrow out. And then that's going to be 2 and 4. So we're looking for a contradiction. We can build that contradiction using 3 and 7 and in. So that's 1, 2, 3, and 4. We've got a contradiction that depends upon our PA and 4, so we can tilde out on our PA and 4. Of our contradiction in 8, tilting out. 1, 2, 3, 4. 4 drops out, so it's just 1, 2, and 3. Now we've got one part of it, so we just need to get the T, and we're just going to do the same thing as before. So tilde T, it's a PA, and then we're going to wedge in the tilde P, so it's going to be 10, wedge in, 10. Then we're going to get the tilde Q out from 1 and 11, arrow out. 1 and 11's 1 and 10, and we can toss that into the conditional 2, and that's going to be 1, 2, and 10. So that's going to be 3 and 13, ampersand in, 1, 2, 3, and 10. Now we got a contradiction, depends upon our PA and 10, so we can tilde out 10, 15, tilde out, 2, 3, 10. The 10 will drop out because of the tilde out. And then we just got to put them together. So that's going to be P and T. It's going to be from 9 and 15 and N. So that's this proof, but the important thing to see here is that this and this are pretty much identical. Just a few differences in the numbers. Because we proved our P and then we proved our T, and the steps were pretty much identical, but you have to repeat them. You may ask, well, why do I need this one here when I already have it here? And I've mentioned this before. It's because this one in line 5 depends upon the PA in 4. And we're not trying to operate on that PA. We can't introduce a PA into another subproof, what we call these things that I've got boxed off here. Because then it contaminates the proof, and you have a PA, you have something that you posited into the proof that lingers. So what you need to do is you need to make your PA and build with that. So we have to make this one in line 11, and then same thing follows from everything down here. You have to have all these different steps because it needs to depend on 10. So that's the first one. Here on 2, we don't have anything next to our conclusion. It's just a single letter. But looking at the proof, I can't do anything to get P by itself. There's nothing that I could possibly do. So let's just assume it's opposite in 4 as a PA and look to prove a contradiction. So, uh, so we can toss this tilde P into our conditional statement in 1 to get tilde S. So that's going to be 1 and 4, arrow out, 1 and 4. Then we can wedge in our Q from 5, wedge in. Now we can toss this not S or Q into our conditional statement 2 to get T and tilde R from 2 and 6, arrow out, 1, 2, 4. And we're still looking for a contradiction. Well, we can get a contradiction by removing the tilde R out of 7. And then putting that with our R in line 3. So that's going to be 3 and 8 and in. 1, 2, 3, 4. And just one extra line because if we got a contradiction, depends upon our PA, so we can tilde out on our PA. And the 4 will drop out because we're doing tilde out, and that's problem 2. In problem 3, our main operator in our conclusion is a conditional, an arrow, so we know that we're going to look to assume the left side and look to derive the right side. So we're going to assume T, and we're going to try to derive P and Q. Now, let's just go ahead and do one step first, and that is we know we can use our T to get our tilde S out doing 2 and 3, arrow out. Now we can't really do too much. There's nothing that we can really do in this situation. Can't use tilde S for anything, can't use T. I don't have tilde P and Q anywhere, can't create it. So I'm going to assume the opposite of of the consequent that we're looking to prove. So we're going to do tilde P and Q. It's going to be a PA. Remember that whenever you have a conditional statement as your conclusion, it's pretty much like this is a new premise that you get, and this becomes your new conclusion that you're looking to derive. So same principles as how would I derive P and Q? Well, I would derive it by finding P and then finding Q and then putting them together. Well, I can't do that here, so let's assume the opposite and look to prove or look to derive a contradiction. So now we do have tilde P and Q, and we can get S from 1 and 5, arrow out. And then we can get a contradiction by putting S and not S together. Sorry, that should be a 5 there. So that is 4 and 6 and in. 4's got 2 and 3, so that's 1, 2, 3, and 5. Now I've got a contradiction, depends upon my PA, which was P and Q. So I'll tilde out on 5. So it's 1, 2, and 3. The 5 will drop out. Now I've got to my consequent. I arrived there with a PA of my antecedent, which was T, so I can build P and Q. From 3 and 8, arrow in. 1, 2, the 3 will end up dropping out. And then we don't need these down here. So now that we're getting to a little bit more advanced proofs, it's still thinking about what you need to do by looking at the conclusion. Conclusion's a conditional. Need to assume the left, look to derive the right. Once you try to derive the right-hand side, if you can't derive it with what you've got, then assume its opposite and look for a contradiction. So here on 3, the main operator in our conclusion is the tilde in front of the statement there. So we're going to assume the opposite of that. So we're going to assume P or Q, arrow T as a PA and look to get a contradiction. Then we'll arrow, or not arrow, but we'll tilde in at the very end. So what can we do with what we've got? Well, the only thing we can really do is break up 2 right away. So we'll do that. 2 and out, 2 and out, 2 and 2. Then we can toss a tilde P into our conditional statement 1 to get S. So that's going to be from 1 and 5, arrow out, and 1 and 5 have 1 and 2. Now, what else can we do? Well, we can wedge in a P to our Q, so that would be 6, wedge in. And we can do that to toss it into our conditional statement in 4. I do need to get rid of it. There's not supposed to be a tilde there. Sorry about that. So I can toss it into 4 to get T. So that will be 4 and 8. Arrow out. 4 and 8. It's 1. Nope. Nope. 4 and 8 have 2 and 4. Now with this I can toss it into 3 to get tilde S. So that's going to be 3 and 9. Arrow out. 3 and 9 is 2, 3, and 4. Then I can put them both together. From 7 and 10. And in. And then now we've got a contradiction. Depends upon our PA, so we can tilde in on our PA. And that's going to be from 4 and 11. Sorry, this is a little bit close to the screen here. Tilde in. And it's going to be from 1, 2, and 3. The 4 will drop out. So that justification just goes a little bit up there. But here again, we just see how we got to look at the conclusion. Conclusion's a tilde. We assume it's opposite everything that's on the side, the right side of the tilde. We're going to assume it. And then look to derive a contradiction, which I did here. This one should have been 1, 2, 3, and 4. And then from our contradiction, we can tilde in using our tilde in rule. So here on 5, the main operator in our conclusion is a tilde. So we're going to assume the opposite of the conclusion, which is just S and P as a PA. And we'll look to prove a contradiction. We can break this up using our and out on 3. Now we've got our 2 antecedents to our 2 conditionals. So I'll toss P into line 1 to get Q and tilde T from 1 and 5, arrow out, 1 and 3. Then same thing with the S and 2, so we can get Q, arrow T from 2 and 4, arrow out. So that's going to be 2 and 3. Now I'm going to break up the Q and tilde T from 6. So that's going to be 1 and 3. And now I can toss this Q to get my T from 7 and 8. arrow out. 7 and 8. It's 1, 2, and 3. Then we can put our two t's, our t and tilde t together. So that's going to be from 9 and 10 and n. So it's going to be 1, 2, and 3. So we got a contradiction, depends upon our PA. So we can tilde n on our PA, like so. And that's going to be 3 and 11, tilde n, 1 and 2. The 3 drops out once we do the tilde n. So that is problem 5. Here in 6, our main operator in our conclusion is ampersand. So we need to prove this side, and then we need to prove this side, and then we'll put them together at the very end. So to prove this, let's just start with the tilde p and t. How do we prove a tilde? Well, we assume it's opposite, and we look to build a contradiction. So PA 3. Then we're going to separate these two out. 3 and out, 3 and out. Now we can wedge in the two disjuncts that we need to be able to get our two arrows out. So I'll wedge in Q to P. And I'm going to wedge in R to T. It's going to be 5. Wedge in. So now I have the two antecedents to my two conditionals, so I can get S from 1 and 6. Arrow out, 1 and 3. And tilde S from 2 and 7. Arrow out. Now I've got my contradiction. So that's going to be 8 and 9. Ampersand N. 1, 2, and 3. Now I can tilde N on my P and T from 3 and 10. Tilde N be 1 and 2. The 3 drops out, and then we're just going to repeat the same exact thing we just did, but using Q and R. So it'll be a PA. We'll separate them both out. Gotta make sure that I write the right letter. 12. Then we're just going to wedge in the P to the Q, T to the R. 13, 14, wedge in, wedge in. 12. Then we'll get the S from 1 and 15. Arrow out. 1 and 12. And then tilde S from 2 and 16. Arrow out. And S and not S from 17 and 18 and in. And then we can tilde in on our PA from 12, 19, tilde in. 12 will drop out, and then one extra line to just put them together. So that's going to be from 11 and 20 ampersand n. Now again, this is a really long proof, but if you realize from here and from here, those are the same exact proofs. Yet, and outs, wedge ins, arrow out, arrow out, arrow out, arrow out, ampersand in, tilde in, tilde in. So the point is that you need to identify the conclusion. You can see that it is a ampersand, so you need to prove each side individually and then worked to put them together at the very end. So since I just erased some of this stuff, I want to make sure that you get a clear picture of what the proof is. Make sure I didn't lose anything else. That looks good. All right. Here in 7, our main operator is a tilde in the conclusion, so we'll assume the opposite and then look for a contradiction. So we can separate this P and Q out. And then we can toss each one of them into their respective conditional statements. So that's 1 and 4. Arrow out. And then tilde R or T from 2 and 5. Arrow out. We're looking for a contradiction, and we still don't have it yet, but we can build one since we have a tilde right here. And we've got one of the disjuncts. We can wedge in the R to T from 6, wedge in. And then we can put those two together. From 7 and 8. Now we got a contradiction, depends upon our PA. So we can tilde in on our PA. That will be 3 and 9. Tilde in. 1, 2, and 3. 3 drops out since we do tilde in. And so that is problem 7. Problem 8 here can be a little tricky because the main operator in the conclusion is this wedge, and usually when we see a wedge we just say, hey, let's just prove either P or Q, and then we'll wedge the other one in. Well, looking at what we've got in our premises, we can't really do anything with what we've got. So since we can't do anything with what we've got, let's assume the opposite of the conclusion. And then try to prove contradiction. So we can toss our PA into line 1 to get S and T from 1 and 3, arrow out. Then we can break apart S and T from 4 ampersand out. Now that we've got these two, we can get tilde S from 2 and 6, arrow out. And now we got our pieces for a contradiction. So that's 5 and 7, ampersand in. 1, 2, and 3. Now we got a contradiction, depends upon our PA and 3, so we can tilde out on our PA. And that will drop 3 out as we do tilde out, so we don't need 10 here. But that's problem 8. Here on 9, our conclusion is just a single letter, but there's no way of deriving it from what we've got. We can't do anything with what we've got, so we'll assume it's opposite and look for a contradiction. with our PA, we can get Q, arrow, S, and T out. From 1 and 3, arrow out, 1 and 3. Now we can separate our, well, we could have done this before, so it doesn't really matter the order in which we do it, but I'm just going to do it now. So I'm going to separate the ampersand from 2, and we can toss the Q into the conditional statement in 4. So that's going to be from 4 and 6, arrow out, and then 4 and 6 are 1, 2, and 3. We've got a tilde S, so let's separate out the S from 7 and out. And then we'll put together. And now we got a contradiction, depends upon our PA. We can tilde in on our PA in 3. Contradictions at 9, tilde in. 1 and 2, the 3 ends up dropping out. So here at 10, we have a conjunction as our main operator and our conclusion. So we need to prove each side of the conjunction. So we'll prove the left conjunct and then the right conjunct, and then we'll put them together at the very end using ampersand in. Now, before I get into the PAs, I'm just going to go ahead and separate both of these statements into their simplest parts. So this one's 1 and out, 1 and out. This one's 2 and out, 2 and out. It will help a little bit once we get going and we can see things a little bit better. So here at 7, we'll make our PA for P arrow S, so the opposite of this conjunct. Now I can toss the P into here. I can get S from 3 and 7, arrow out, 3 and 7, 1 and 7. Then I can put put S and tilde S together, doing 5 and 8, ampersand in. And then we can tilde in on our PA from 7. So this could be 7, 9, tilde in. The 7 drops out. Now we've proved this one, so we got to prove the right conjunct. And so we'll assume its opposite as a PA. And then we'll look to prove a contradiction. I can get T from 4 and 11, arrow out. So it's 1 and 11. And then I got a tilde T from 6, so I can do T and tilde T from 6 and 12, ampersand in. So that's going to be 1, 2, and 11. I got a contradiction, depends upon my PA, so Q arrow T. So that's going to be 11, 13, arrow, tilde in. The 11 will drop out. Now we've got both of our conjuncts. So we'll put them together. That's going to be 10 and 14 and in 2. And the rest of these we don't need. But the reason why I broke this stuff up before, so I broke all this stuff up because this is all coming from our premises. That's why there's nothing but 1s and 2s. And then everything here depends upon a 7. The 7 drops out here too. And then everything depends upon 11. 11 drops out here. Here on 14. But I just broke everything up in the first handful of lines, so then you could see that this, or I guess I should do this, and this are the same exact proof, arrow out, ampersand n, tilde n, on both sides. So doesn't really matter the order. We could have made our PA up here at 3, then we would have had break stuff down, and then it would have been a little bit longer on this side, and then we would just have to do the opposite thing on that side. It doesn't really matter the order which we do stuff in, as long as we do it accurately using the rules correctly. So, but that is problem 10.